Right, here's an example, a little thing I knocked up to illustrate it, hopefully as many points as I could think of, since this is a bit easier to explain it on this than to try and write it all down in words. Okay, what we've got here is a whole load of classes and interfaces, and you can see there's only like one method we're concerned with, and that's M. Obviously these lines here represent extend, and the dotted ones represent implements. So class C2 implements I4 and so on. Yeah, the idea. Okay, so the question is, what sort of restrictions are imposed on these T's and these E's as a result of this arrangement of classes and interfaces? Right, that should cover everything, so let's start. Okay, first of all, if you put I1, I2 and I3 in just like that into a file, you can compile them by themselves and it's quite happy. Right, so there's no problems with those. Now the minute you put I4 in, because I4 extends I1, 2 and 3, there's some checking involved, because they all I4 inherits method M from each of them. There's a check, and the check is that T1, T2 and T3 are return type compatible. What that means is it takes a look at T1 and T2 and it says, right, one of them has got to be a subtype of the other, or they've both got to be equal. Doesn't matter which way round it is. T1 could be a subtype of T2, or T2 could be a subtype of T1. Doesn't matter. They're both, or they could both be the same. So it does that, and then it does it for T1 against T3, and then it does it for T2 against T3. So that's the check when you get, if you just put I4 in like that. And it pays no attention to what E1, E2 and E3 are. Right, now if we come round to I5, what it does is, first of all, it does this check just like it did for I4 with T1, T2 and T3, and then it checks the return type T5, and it says that T5 has got to be a subtype of T1, and then it says that T5 has got to be a subtype of T2, and then T5 has got to be a subtype of T3. Okay, and then it checks the throws clause, and basically it can only throw, because this could be a list of exceptions down there and a list of exceptions up there, so what it means is throws clause has got to be compatible, so any exception in this list down there must occur in this list of exceptions up here by E1, or it's got to be a subclass of some class in this list for every class in this list down here. Basically, if you put a try and a catch for every single catch for each individual class in this list, this E1 list, then it's got to catch every single thing in this list. It's got to be caught. That's basically what it means. And it does the same thing again for E2 and against E5 and for E3 against E5. Okay, so that's fairly straightforward. And what about this abstract class C1 here? Well, this again is overriding. So what happens is it checks T7 to make sure that that is a subtype of T1, and it checks that the throws clause is compatible So E7 has got to be compatible with E1. And don't forget, these could be a list. I didn't put a list in here because it just gets too wide. It doesn't fit on the page. Okay, so that's the check that goes on there. Alright, now what about here? Here we've got a concrete implementation. And the check is really just the same. It checks that T8 is a subtype of T7 and that E8 is compatible with E7. And then it checks that T8 is a subtype of T1, and then that T8 is a subtype of T2, and that T8 is a subtype of T3, and then that E8 is compatible with E1, and then E8 is compatible with E2, and then E8 is compatible with E3. So all that goes on. Right. Although, of course, it may actually, if it's clever, it may shortcut and realise it doesn't have to check the compatibility of T8 against T1, because that's already occurs when you go through via the abstract class. And usually, I think it is clever actually not to realise that. Right. Now, of course, it can stand alone by itself. So we're left with C3. Now with C3, there's nothing declared for M in C3, so it simply inherits it from C2. And what happens when that occurs is, it being a concrete class, that's going to take priority. So it will make sure now it's just as if that was declared in there. So it will check T8 to make sure it's a subtype of T5, and then make sure T8 is a subtype of T6, and then check that E8 is compatible with E5 and that E8 is compatible with E6. That's what happens when you compile C3. And that's about it. So it's really not too difficult. You've just got to remember that if you get a class like that, it just checks the return types are compatible. That's all it does. It doesn't do anything with E1. It's only when you override with something that it checks E1. The throws clause. And of course also it's going to check compatibility with what's overridden. Right, now you might say, well, what happens with statics, because this is all instant stuff. Now with statics, static methods, the situation is really simple, because they're static, interfaces don't play any role. Because remember, interface is abstract and you can't have an abstract static. So interfaces play no role, and it's just simply classes all the way up and down, and it's really straightforward. So there's never this problem with static stuff. Not that this is a problem, it's